Bismillahirrahmanirrahim. This video is from chapter number 2 of Mr. Floyd's book on digital electronics, and here I'll be solving a couple of problems which I call practice problem. Actually the book is calling it related problems and checkup problems. But these are very simple. Primarily these questions are designed for these computer science students who are also studying DLD nowadays. So let's proceed. First question is the conversion from binary to decimal. So this is the binary number we have to convert into a decimal number. And the best way is to use this weight table or weight line. Start from 20 to 122. And the actual value, I hope you know it, 20 is equal to 1, then 2 power 1 is equal to 2. And you keep doubling, so 4, 8, 16, 32, 64, 128. And now we will align our given number with this. So this is the given number we are aligning like this. And now we will note down the values where it is 1. So we can say that our binary number base 2 is 1 is at 128, so 128, plus 1 is at 16, so plus 16, and 1 is at 1, so 1. So the total number is 145 base 10. That means this is the decimal number. Now I'll tell you a trick by using your calculator to confirm your answer. And that is, let's say this is our calculator. We go into the mode and we select base n. So 4 is base n. And now you can see this is for decimal, this is for hex, then binary and octal. So these 4 buttons. We want to input binary numbers, so we'll select binary. And now we'll input 1001, so 1001, then 0001, and we'll press equal sign, and we want the answer in decimal, so press this decimal button. So 145, so 145 is the answer. That means our answer is correct. The next number is this binary again, but it is in fraction form, so 10.111, and this we have to convert into decimal. Again we'll follow the same technique. We'll get this weight table, but now this time we have included the decimal part of the table as well, because ours is 3 digit to the right of the decimal. Align it. So align this here, and same technique. We'll just write that this is equal to 1 is at 2, so 2, then 0, 0, 1 is at 0.5, 1 is at 0.2, and 1 is at 0.125. So the answer is 2.875. Now unfortunately in the calculator there is no direct way of doing the fractional part, so we have to modify it a little bit, and the modification is that we remove the decimal, so this will become like a whole number, and we have moved 3 places. We have moved the decimal 3 places, so we'll divide it by 2 raised to the power 3. And this binary we can convert into decimal as we did earlier. So let's do it. 10111. So we first of all go to binary. 10111, and we'll find its decimal equivalent equal to decimal 39. Oh, I missed. I added an extra 0. Delete. Okay, equal binary now equal to decimal. So 23. So 23 is the answer for the from binary to decimal conversion. Now we have to divide it by 2 raised to the power 3 or 8. For this we have to move into mode 1 here, that is composite 1. So we press 1 and now we'll write 23 divided by 2 power 3 equal sign 23 over 8. We use this button ST to get it into fractions. So 2.875. That means our answer is correct. The next is convert the binary number. Again, this is a slightly bigger size, but this is also a fraction number. So we'll follow exactly same technique. We are now using the bigger table, aligning everything, and wherever there is 1, so we'll write the value. So 1 is 128, then 1 is at 32, then 16, 8, 4, 1, and then we have 1 at 0.25 and 1 at 0.125. And so this is our answer. Here also you can verify it. We have to move 3 decimal to the right, so we get this number divided by 2 raised to the power 3 because we moved 3 places. This, when you convert into the decimal, you will get 1515 divided by 2 over 3, and as we did earlier, you will get this answer. So let me show you. Mode we have to change to 4, and we go to the binary 10411011111, then 01011011011. This is equal to, now the decimal is 1515, and this now we have to divide it by 2 over 3. We change the mode, go 1 composite, answer divided by 2 power 3, or 2 power 3 is 8, so we'll divide it by 8. So this is the answer, and we SD, so 189.375. So this is also verified. The next is opposite from decimal to binary, but there are 2 methods. So he is saying that find it by sum of weight method. So we have already done this type of question, sum of weight. So we'll just get the weight table here, and now 125 we have to distribute between these. So 125 can be written as 64 plus 32 plus 16 plus 8 plus 4 plus 1. Now this is slightly cumbersome. You have to guess what is the number. So there is an easy way, and that is we subtract from 125, we subtract the next number. Obviously we can't subtract 128, so we subtract 64, so we get answer 61. From 61 the next number is 32, 29, the next number is 16, 13 minus 8, 5, and 5 minus 4 is 1, and now we can't subtract 2, so that will be left blank, and 1 minus 1 is 0. So these are this number here, we will write it here. So 64, 32, 16. So this way it becomes easier. And now we have to just write down the values in a power form. So 64 is 2 power 6, then 2 power 5, 2 power 4, 2 power 3, 2 power 2, and 2 power 1 is not there, so we'll write 0, and then is 2 power 0. And for every values we'll write 1 except for 0. So 1, 1, 1, 1, 1. So this is the answer, and I hope now you can easily verify with the help of your calculator. This is simple, there is no decimal, so you can easily verify from 125 to this value. So let's see, calculator mode change 4. Now we have decimal value, so decimal, it is showing decimal, so we'll write it 125. Sorry, it is just jumping. So 125 equal binary, and you can see 5101. So we have 5101. So this is the answer. The next question is 39, but we have to find this by repeated division method. And the repeated division method is just you keep dividing by 2. So 39 divided by 2, we get 19 and carry 1. Then 9 divided by 2 is 4, carry 1. And 4 divided by 2 is 2, carry 0. And 2 divided by 2 is 1, carry 0. So this is the answer. Now we'll write it from here. We will follow this, because this is our MSB, most significant bit. So we can say that 39 is 1, then 00, then 111. So this is the value, and you can again verify this with your calculator. The next is convert. Now this is the checkup question. Convert the decimal number to binary using sum of weight method. So there are two methods. So this is sum of weight method, and in sum of weight we have already done. We'll use the table. So this is the weight table that we will use, and 45 can be written by these values. Same technique, 45 minus 32, 13, 13 minus 8, 5, 5 minus 4 is 1, 1 minus 1 is 0. So these are the values that we have to write. So 32, 8, 4, 1, and for decimal or 0.5, we just write it 0.5. And now in terms of 2 powers, so we wrote these wherever there is a gap. 32 is 2 power 5, but 16 is not there, so we'll put a 0. 8 is 2 raised to the power 3, then 4 is okay. Then 2 is not there, so we'll put a 0. Then 1 is 2, 0, and this is 2 minus 1. So for all the values we'll put 1, wherever there is 0 we'll put 0. So this is our answer. And this you can verify again from decimal to binary. Now the technique is slightly different from binary to decimal, and that is, the difference is that whatever is the number, we multiply it by 2 power some value. Generally it could be from 2 to 6, so I'm taking 3. So whatever value you take here, you have to shift, or the right at the bottom, shift by that digit. So since we have taken 3, so we'll write shift by 3 digit. Now if you multiply this to 2 raised to the power 3 or 8, you get 364 base 10, and then you just copy this one. Now 364 base 10 can be converted into binary, and you will get this value. Now we have to shift it by 3. Shift the decimal. We assume that there is a decimal here. Shift 3 places left. So this is the answer. And after decimal, there is no point keeping zeros. So this is our final answer, which is same as what we got here. So let me just show you now. First of all, we do the multiplication. We change the mode and go to the composite mode. 45.5 multiplied by 2 raised to the power 3, that means 8. So we get 364, and we will now convert this into binary. To change the mode, base 4, decimal 364, 364 equal binary. So you can see it is 10111011 10111011 10111011, and then we have 2 zeros at the end. So we got this, and now shifting 3 digits, this is the answer. Eliminate the last two, so you get the same answer. And finally we have fraction again, but it's a small one, 0375. Now for whole number we divide by 2, but for fractional number we multiply by 2. Repeated multiplication by 2. Okay, now 2 multiplied by 0.375, so we get 0.75. So this, the left digit will be our carry, so it is carry, and in this case repeated multiplication, this will be the MSB, most significant digit. So we'll go from here, noting down. Okay, now we copy 0.75, multiplied by 2, it becomes 1.5, so 1 is carry, so written down. 0.5 will bring to the left, multiplied by 2, it is 1.00, so 1 is our carry, and so that is the answer, 0.011 for 0.375. And this one also you can verify with the help of your calculator, as we did in the previous case. So I hope you have been able to follow this. Okay, here I have just written down what to do. 0.375 multiplying by 2, 3. So when you multiply this, you will get 3. We have to shift by 3 digit. 3 converted into binary will be 1 1, and shifting by 3 digit we get this answer, which was the same that we got direct methods. Thank you.